because this section talks about set notation, let me put a little bit here about that. Set notation is when you use the braces, okay? And we've already used that. I meant to say let's talk about interval notation. This is one way to write your domain and range, and sometimes your book's going to use this. But there's another thing it uses, and it's called interval notation. And interval notation usually confuses people because they think they're looking at a point sometimes. Let's say that my domain, I'll use set notation here, and I'll write something in interval over here just so we can compare it. For instance, let's say I had that -2 is less than or equal to t is less than or equal to 2, and that's my domain. How I would write that in interval notation is first of all to notice that these have these equal signs under them right here and here, which means count the endpoints. If I wanted to count the endpoints, how I would write that is to use square brackets. I would say all my numbers are in between -2 and 2. When you see something like that, you know that they're talking about that they could write domain, and they could write it that way, or they could have in set notation have written it this way. So in set notation it would look like that in the braces. In interval notation though, you would use those closed symbols, and you're showing you want everything in between -2 and 2, and these square brackets means count the endpoint. Let's look at some other things though, because this can kind of get confusing the first time you have to mess with it, and I don't know if we've really messed with this much or not. What if I had -2, maybe I'm writing this in set notation, that's supposed to be squiggly brace, and I messed it up. Let me do that a little neater. What if I had -2 is less than t is less than 2? The only difference here is I didn't put the equal sign under the inequalities. What would that look like? If you don't count the endpoints, you use parentheses. And it looks like this. What does this look like? A point, doesn't it? So you see how you got to really look at the context of what you're doing? That's not a point anymore. Now it's interval notation. It means everything in between -2 and 2, but don't count -2 and 2. They don't work. Okay? What if it was this? Okay, you know it's going to be -2, 2, right? What will I do to show this equal sign on this end down here? If I want to count the endpoint, I make the real blocky, square bracket looking thing like that. But on the other end, there's no equal sign. So how do you think I'm going to show that? The rounded one, right? So you can have all kinds of mixed stuff. It just depends upon your inequalities here when you're writing your domain and range. So you're going to start seeing the book. Sometimes they'll use one thing, sometimes they'll use the other. You're rarely, if they never say anything about the domain or range, you assume it's real numbers unless you see something in the thing like a even root of a negative number or something that could make the denominator 0, and they're asking you to tell what you should exclude, okay? What if I had this? What if I had a line? How would I write the domain of that? I could say all real numbers. That would be set notation. In set notation, you can use the braces, or sometimes you can just use this. This is still considered set notation. Doesn't this go from -infinity to infinity? Right? So you would write it this way, okay? And you saw a little bit of this, I think, in that parent function thing you did. Do you think I'm going to put the blocky brackets are called closed, which means you count the endpoint. The parentheses looking thing are it's called open, and those you do not count the boundary value or endpoint I'll put endpoint just because it's a shorter way of saying it. You think with infinity and negative infinity, am I going to put square or just the regular parentheses? Y'all got any ideas about that?
If it's trying to show that I can do anything, then maybe we'll go ahead and do the square.
You would think. Here's the thing that makes the difference. Is infinity a number? No. So they end up doing this, because since infinity is not a number, you would think you would make them blocky, because you think, oh, I want to count anything that I can think of that's that big. But because it's infinity, you do that. Okay, you use these rounded ones. What if you had a function that looked like, I'll draw something. Maybe you got some kind of square root function. Okay, that's a square root function. We could just say, in set notation, we would say x is greater than or equal to 0 for our domain. Range works the same way. You would just have an r out front, you know. We'll do the range on this one too in a minute. How would I write that in interval notation? What's my endpoint on the left? 0, and then on the right it's infinity. Am I going to count 0? Yes, it's colored in, okay? So since it's colored in, I'm going to count it. I'll make a blocky one there, but on infinity, what do I do there? Just the, yeah, I hear a couple. See, I see her, and I heard it back there, parentheses, right? It's easy to look at the function usually on the graph and get your domain and range sometimes easier than it is to try to figure it out algebraically. Do you see how easy it is to get that here? I mean, we can see it really easily. Let's talk about the range just because we haven't done that yet, and you can do this on the range also. What is the lowest y value that this function has? 0. Yeah, here's our y values. The lowest one is 0. It's colored in, so we count it. So I could do y greater than or equal to 0 for the range. Or I could come over here, and my lowest y is a 0, and it's colored in, so I'm going to make it a blocky bracket. And then it goes up to infinity, so what will I do with this one? The curved one, yeah. Okay. An even function is, here's how they tell you the rule for it. They say f of x is equal to f of negative x. Okay. That's how you know if you got an even function. What does that mean? If I have 2 here, the y values, let's say that's 2, it's right there. If I have negative 2 over here, doesn't it have the same y value? I drew a very sloppy graph, but in theory it would if it were drawn really neatly, right? Don't they have the same y value? So even though I've got an x that's positive, when I stick a negative on it, it still has the same y value. That's what it means to be an even function. So how do you prove something is or isn't an even function? You do the math on this. So let's pick one from your homework that talks about even and odd. If I plug t in, I have what's written there, t squared plus 2t minus 3. Now let's plug negative t in. So here's what I'm going to do. I'm going to go to the function. Everywhere I see a t, I'm going to put a parenthesis so I can plug a negative t into it. And I'm going to do that just because this gets hard, you know, to think about sometimes when you're plugging in a negative number. So I know the function with t plugged in is just what they wrote, but let me put a negative t in there and see if it ends up being the same thing. Okay, so negative t squared, wouldn't that just be t squared, right? Square a negative, you get a positive. Y'all agree? Okay, so I'm going to write t squared down. 2, positive 2 times negative t, though, would be negative 2t. And then I could copy down the minus 3, but this is what messed it up. It has a different sign, doesn't it? So this is not even. That doesn't necessarily mean it's odd. Let me show you. We'll test this same one to see if it's odd. An odd function, if you put, let me make sure. An odd function, if you were to plug f of a negative x into the problem, it's equal to the negative of just f of x. This would be kind of like a reflection, if you think about it, of a value. All right, so what is, if I'm plugging negative x, I'll do it with x's here. Here's my function, t squared plus 2t minus 3. And even though they wrote it with t's, I can plug x's into it. Let me plug a negative x into it. Oh, sorry. So I'm plugging in negative x.
Is it recording?
Yes.
Oh.
So negative x squared would be x squared, right? Positive 2 times negative x would be negative 2x. And minus 3. So that's what I get when I plugged negative x in. Now, I'm going to do it again, except this time I'm going to put negative f of x. If I plug x into t squared plus 2t minus 3, it would just be x squared plus 2x minus 3, right? I'm putting the negative out front, and if I wrote this function that I'm looking at right here, and I just put x's in place of t's, that's all I'm doing, right? Because this is telling me put an x into this. Okay. When I go to distribute the negative, I get negative x squared. Oops, it's already different, isn't it? I could just stop there if I wanted to, but I'll go ahead just to make sure. That would be negative 2x and then positive 3. I could have stopped once I saw that this was different from this. This is neither an even nor an odd function. They don't have to be either one. It's nice if they are. There's special things about them if they're even or odd that you'll find out, in higher math that'll help you work easier with stuff. In calculus, we talk about this a little bit. But this is neither even nor odd. Because we tested it for both. So just because it's not even, don't go, oh, it must be odd, because, not, this one was an example of something that was neither even nor odd.